3.7 billion years ago, the first teeny tiny organisms called microbes appeared on Earth. While their size and complexity may not be all that impressive at first glance, they set the stage for all life on Earth.
When you say teeny tiny, Louise, how teeny tiny are we talking?
Well, the first life on Earth was so small that they were microscopic, which means that they can't just be seen with our eyes.
Wow!
It's crazy when time passes, or when you feel 2 feet tall, like who, what, where, when, how, why. Everything stops, what's with it all? You could scale a mountain, you could climb a tree, or you could cross a river. You could do whatever your heart desires. It's a wild, wild world. Would you agree? What a wild, wild world.
Life began on Earth in the ocean, with very simple beings only made up of one cell. These are bacteria.
It took millions of years for these bacteria to become more complicated. One of the superpowers of some of these newer, more complex bacteria was the ability to turn the sunshine into food. Hey, Louise, I have a question. How do we know about organisms that existed so long ago?
Well, that's a great question, Morgan. Paleontologists use fossil evidence to learn more about life on Earth in the ancient past.
That's so cool! What's a fossil?
I'm glad you asked. Fossils are the remains or impressions left behind by a prehistoric organism, like a plant or an animal. Because life is made up of things like bone and tissue that break down really easily, the fossils we usually find are formed by imprints left behind.
Wait, so when I see a dinosaur in a museum, those aren't really bones?
No, as the bones wear away, they leave an empty space in the rock where other minerals can sneak their way in, taking the form of the organism that used to be there. This can be kind of confusing, but I think I know a way that we can all understand how fossils are formed.
No, boy!
In order to mimic the process of fossilization, you'll need plaster of Paris, a cup of water, a disposable cup, and an object you'd like to fossilize. If you're following along at home, you'll want to scoop 2 parts plaster of Paris, and 1 part water. You should have a mixture that is thick but still wet. Now, you're going to place your object into the plaster and set it aside to dry overnight.
Oh, our fossils are done!
With the help of an adult, you can pry your object out. You may need to use a key or a butter knife.
Wow! Look what's left behind! I can see the footprints of where my dinosaur once walked!
These indentations in the rock are created over time, and minerals fill in the empty spaces that they form, leaving fossil clues into the past for paleontologists to study.
I think I get it now. I think I could recognize a shell and a footprint if I were a paleontologist. But how do paleontologists find clues of the earliest life forms?
Finding fossils in our most ancient rock formations is rare, since these simple organisms don't have bones or shells that fossilize easily. However, paleontologists have found evidence of our earliest life forms on Earth. Let's take a look at a real-life fossil. When interacting with a new fossil, we can always start by identifying 3 things that we notice.
Well, first off, I'm noticing that this fossil has a wiggly stripe pattern. Also, each stripe is a different color. Oh, I also see that none of the stripes cross each other. They each build on top of the next stripe.
Those are excellent observations, Morgan. This fossil is a Precambrian stromatolite.
Stromatolite? Is that like a microbe?
Not exactly. Sometimes we have to study the traces left behind by animals, like when we made that fossilized footprint earlier. Evidence left behind can tell us a lot about the creature who made it. These microbes are called cyanobacteria, and they produce a gluey mucus that traps sands and creates what's referred to as a microbial mat. Do you remember what these microbes eat, Morgan?
Oh yeah! They turn light from the sun into energy!
Right! The cyanobacteria continue to grow towards the sun, where they generate a layer of mucus that attracts more sand.
I think I'm starting to notice a pattern here.
Right. This process of building up sand layer by layer creates a wiggly stripe pattern that you observed in our specimen. We find examples of these formations all over the world. The sand deposited in this sticky mucus tells us just how widespread cyanobacteria were.
It's cool that such tiny lives can leave such a big trace.
And not only did microbes create these awesome rock formations for us to look at, but their ability to photosynthesize, or turn the sun's light into energy, also meant that they created the rich oxygenated environment that animals breathe in today.
Wow! So these little guys set the stage for all animals? You? Me? Dinosaurs?
Right, Morgan. And we're going to learn about some of those more complex creatures really soon. But today we learned that fossils are made by animal and plant remains, creating impressions that are then filled with sediment.
We also learned that these fossils help us learn about ancient life, like cyanobacteria.
Thanks for joining us, curious folks, and we'll see you next time on BASECAMP.
It's crazy when time passes, or when you feel 2 feet tall, like who, what, where, when, how, why. Everything stops, what's with it all? You could scale a mountain, you could climb a tree, or you could cross a river. You could do whatever your heart desires. It's a wild